The serial killer beneath our feet. How Earth itself murders civilizations. Here's a thought that should keep you up at night. You know that asteroid that killed the dinosaurs? The one every documentary and textbook tells you about? The 10-kilometer-wide space rock that slammed into Earth 66 million years ago and ended the age of giants? Yeah, that one. What if I told you it might have just been the accomplice? What if the real killer had been murdering slowly and methodically for 800,000 years before that asteroid ever showed up? And what if that killer is still down there, sleeping beneath your feet right now, waiting to wake up and do it all over again? This isn't speculation. This isn't some fringe theory from a conspiracy documentary. This is cutting-edge paleontology, and it's forcing us to completely rewrite one of the most famous stories in natural history. Because it turns out the death of the dinosaurs wasn't a sudden catastrophe from space. It was a slow-motion apocalypse that turned violent, a murder mystery with 2 suspects, and the evidence is pointing towards something far more disturbing than a random asteroid impact. The evidence suggests Earth itself is a serial killer. And the dinosaurs? They were just one victim in a pattern that stretches across hundreds of millions of years. So forget everything you think you know about extinction events. We're going to examine the crime scene with fresh eyes, follow the evidence wherever it leads, and by the end of this, you're going to see mass extinctions in a completely different way. Because the monster that might have killed the dinosaurs isn't lurking in space. It's lurking beneath the ground, and it has killed before, and it will almost certainly kill again. Let's start by setting the scene properly, because the world 66 million years ago was nothing like the sanitized museum dioramas you've seen. Earth during the late Cretaceous was a greenhouse planet, not metaphorically, literally. Global temperatures were somewhere between 5 and 10 degrees Celsius warmer than today. There was no ice at the poles. None. Where we have glaciers and frozen tundra, the dinosaurs had temperate forests full of sequoias and ferns that somehow survived months of polar darkness. The air was thick and humid. The oceans were warm enough that tropical conditions extended almost to the Arctic Circle. And life was everywhere, in forms and scales that would seem alien to us now. The oceans teemed with ammonites, those beautiful spiral-shelled creatures that looked like nautiluses, some of them growing to 2 meters across. Marine reptiles the size of school buses hunted in waters that covered much of what we'd recognize as land today. Pterosaurs with wingspans that rivaled small aircraft soared through skies that probably looked more purple than blue due to different atmospheric composition. And the dinosaurs themselves had achieved a level of diversity and specialization that's hard to fully appreciate. We're talking about an animal group that had been successfully dominating terrestrial ecosystems for over 150 million years by this point. They'd survived climate changes, sea level fluctuations, smaller extinction events. They were, by any measure, the most successful large animal group in Earth's history. And then, in what appears to be an instant in geological terms, 75% of all species vanished. Now here's where the standard story kicks in. An asteroid 10 kilometers wide, moving at cosmic speeds, hits the Yucatan Peninsula. The impact releases energy equivalent to billions of nuclear weapons. Tsunamis, wildfires, impact winter, end of dinosaurs, case closed. It's a clean narrative, it's dramatic, it's the kind of explanation that satisfies our desire for simple cause and effect. One event, one outcome. The universe threw a rock at Earth and killed the dinosaurs. Except there's a problem with this story, and it's been lurking in the data for decades. The problem is timing. When you actually look closely at the fossil record, when you examine the layers of rock and the remains of creatures preserved there, something doesn't quite add up. The extinctions don't all happen at the same moment. Some species are already in decline before the asteroid hits. Ecosystems are already stressed. The climate is already unstable. It's like arriving at a crime scene and finding the victim was already bleeding out before the final blow was struck. And this is where our second suspect enters the picture. About 7,000 kilometers away from where that asteroid would eventually hit, on the opposite side of the planet, something else was happening. Something that had been happening for hundreds of thousands of years before impact. Something that, in its own way, was far more terrifying than any space rock. In what is now India, but was then an island continent slowly drifting toward Asia, the Earth's crust had begun to tear itself apart. Not quickly, not explosively, but with an inexorable inevitability that would make the asteroid impact look like a mercy killing by comparison. This is the Deccan Traps, and understanding what they did requires us to completely reimagine what volcanic activity can be. When you think volcano, you probably think of a mountain. Lava flows down the sides, ash shoots into the air, it erupts for days or weeks, and then it stops. That's not what the Deccan Traps were. This was a volcanic region covering roughly 500,000 square kilometers, an area larger than California, and it didn't erupt. It bled. For hundreds of thousands of years, the Deccan Traps pumped out lava and toxic gases in quantities that break our intuitive understanding of geological processes. We're talking about flows of basaltic lava that covered areas the size of small countries in a matter of days. We're talking about gas emissions on a scale that could alter global climate. And we're talking about this happening not as a single catastrophic event, but as a prolonged apocalypse that gave ecosystems just enough time to start adapting before conditions changed again. This is death by 1,000 cuts, geological style, and the evidence suggests it might have done most of the killing before the asteroid ever arrived. Let's talk about how you kill a planet slowly, because this is where the Deccan Traps story becomes genuinely nightmarish. The volcanism began approximately 800,000 years before the asteroid impact. 800,000 years. To put that in perspective, modern humans haven't been around for half that long. This wasn't a disaster, it was an era. And it started quietly. The initial gas emissions from the Deccan Traps were maybe 10 million tons of carbon dioxide and sulfur dioxide per year, which sounds like a lot, but on a planetary scale, it's actually manageable. Earth's natural carbon cycle can handle that. Ecosystems can adapt to gradual changes. For the first few 100,000 years, this was probably just a local problem. The ecosystems on and around India were suffering, but the rest of the world? Largely unaffected. But here's the insidious thing about continuous emissions. They accumulate. Carbon dioxide doesn't just disappear. It dissolves into the oceans. It gets absorbed by plants. It gets locked into rock through weathering. But all of these processes take time. And if you're adding carbon dioxide to the atmosphere faster than these natural sinks can remove it, the concentration builds up, year after year, decade after decade, century after century, for 500,000 years. By about 300,000 years before the asteroid impact, atmospheric carbon dioxide levels had risen high enough to start affecting global climate. The planet began to warm. Not catastrophically, not overnight, but steadily. Temperatures increased by perhaps 2 degrees Celsius over 100,000 years, and at the same time, the Deccan Traps shifted from just venting gas to actively pouring out lava. Now we need to understand what a lava flood actually looks like, because it's not what you're imagining. Individual flows from the Deccan Traps could cover 10,000 square kilometers and be tens of meters thick. Imagine lava moving across the landscape not like a river, but like an ocean wave, inexorable and unstoppable, burying everything in its path under molten rock that would cool into basalt. The forests of India burned, the rivers boiled, anything that couldn't fly away or swim away died. But the real killer wasn't the lava itself. Lava is localized. You can be on the other side of the planet and lava won't touch you. The real killer was what the lava released into the atmosphere. Every time a massive flow erupted, it vaporized any water it touched, releasing enormous amounts of steam. It burned through organic material, releasing more carbon dioxide, and crucially, it brought up gases from deep within the Earth's mantle, including sulfur dioxide in staggering quantities. Sulfur dioxide is particularly nasty because of what it does in the atmosphere. It reacts with water vapor to form sulfuric acid, which falls as acid rain, and in the short term, before it rains out, it acts as an aerosol that reflects sunlight, causing cooling. So here's what happened. The carbon dioxide from the Deccan Traps warmed the planet over long timescales, but the sulfur dioxide cooled it over short timescales. And the timing was chaotic, unpredictable, devastating. Ecosystems that had spent 100,000 years adapting to warmer temperatures suddenly experienced rapid cooling as a massive eruption dumped sulfur aerosols into the stratosphere. Temperatures could drop several degrees in just decades. Species that had moved toward the poles seeking cooler conditions suddenly found themselves in regions that were cold enough to kill them. And then, after the sulfur rained out over the next few years, the warming resumed. Adaptation became impossible. You can't evolve fast enough to keep up with climate whiplash on that scale. Meanwhile, in the oceans, something even worse was happening. The carbon dioxide dissolving into seawater was changing the ocean's chemistry, making it more acidic. This is a problem for anything with a calcium carbonate shell, which includes plankton, the base of the marine food web. As plankton populations crashed, everything that ate plankton began to starve, and everything that ate plankton eaters began to starve. The entire marine ecosystem began collapsing from the bottom up. But the Deccan Traps weren't done, not even close. About 50,000 years before the asteroid impact, something changed. The Deccan Traps, which had been bad enough already, shifted into a mode of activity that can only be described as apocalyptic. The lava output increased by orders of magnitude. We're talking about tens of trillions of tons of magma erupting over a period of several thousand years. For context, that's enough lava to bury the entire continental United States under a layer 30 meters thick. This wasn't volcanism. This was the Earth's interior hemorrhaging onto the surface. And the consequences were biblical. The sheer amount of heat released, the scale of the gas emissions, the extent of the devastation, all of it combined to create environmental conditions that Earth hadn't seen in hundreds of millions of years, and hopefully we'll never see again. First came the wildfires, not just in India, although that was bad enough. The ash and burning material ejected into the atmosphere spread globally. Lightning from the massive ash clouds ignited fires across multiple continents. For thousands of years, large parts of the planet were burning. The smoke and particulates blocked sunlight, causing photosynthesis to decline, which meant plants died, which meant herbivores starved, which meant carnivores starved. The food chains fractured. Then came the storms. The amount of heat being pumped into the atmosphere from the lava flows was so immense that it may have created atmospheric conditions that simply do not exist on Earth under normal circumstances. Some climate models suggest the formation of hypercanes, tropical cyclones, so large and powerful they make modern hurricanes look like afternoon breezes. We're talking about storms with wind speeds approaching 1,000 kilometers per hour, storms tall enough to reach into the stratosphere and literally rip holes in the ozone layer. And when the ozone layer gets damaged, ultraviolet radiation from the sun penetrates to the surface unfiltered. Plants can't photosynthesize properly. Animals get radiation burns. DNA damage increases. Cancer rates skyrocket. The sun itself becomes hostile to life. But wait, it gets worse. Because while all of this was happening, the Deccan Traps were also venting massive amounts of heavy metals and toxic chemicals from deep within the Earth. Mercury, which is poisonous to basically all life. Hydrochloric acid, which is exactly as pleasant as it sounds. These compounds were carried into the atmosphere, spread around the globe, and rained back down onto the surface. The water became poisonous. The soil became poisonous. The air became poisonous. Imagine being one of the last dinosaurs walking around during this period. The sun is dim because of the ash and smoke. The rain burns your skin because it's acidic. The plants taste wrong because they're struggling to grow in contaminated soil. Other species are disappearing around you. The food is scarce. The climate swings between hot and cold on timescales too fast to adapt to. You're coughing from the toxic air. And this isn't a temporary disaster that will blow over in a few years. This has been going on for your entire life, and your parents' entire lives, and their parents' entire lives. There is no memory of the world being any different. This is just how things are now. And then, after thousands of years of this slow-motion apocalypse, after entire genera of species have already gone extinct, after the global ecosystem has been pushed to the absolute brink of collapse, a dot of light appears in the sky and grows brighter each night. And then one day, 10,000 kilometers away on the other side of the planet, an asteroid hits with the force of 4 billion atomic bombs. If the Deccan Traps were a prolonged torture, the asteroid was the final execution. And here's the really cruel part. By the time the asteroid arrived, life on Earth was so weakened, so depleted, so stressed by hundreds of thousands of years of volcanic assault that it couldn't survive both. A healthy biosphere might have recovered from either the volcanism or the impact. But a biosphere that had already spent 800,000 years being poisoned and burned and frozen and cooked, that biosphere shattered completely. So the asteroid hits. The immediate effects, the ones everyone knows about, the tsunami and the fireball and the impact winter, they all happen. But here's what's often left out of the story. The Deccan Traps didn't stop. They couldn't stop. Volcanic processes don't work that way. You can't just turn off a mantle plume because an asteroid hit on the other side of the planet. In fact, and this is where things get really interesting, some evidence suggests the asteroid impact might have actually made the volcanism worse. The seismic shock from the impact, the way it rippled through the entire planet as magnitude 11 earthquakes, may have shaken the magma chambers beneath India and intensified the eruptions. It's like the Earth itself was trying to finish what it started. For another 800,000 years after the impact, the Deccan Traps continued vomiting lava and poison into the atmosphere. 800,000 more years. The planet couldn't heal, couldn't recover. Every time ecosystems started to stabilize, another massive eruption would dump more carbon dioxide and sulfur into the air and reset the clock on recovery. This is why the extinction was so complete. It wasn't just the initial blow, it was the follow-up punches that kept coming while the victim was already down. By the time the Deccan Traps finally went dormant about 65 million years ago, 75% of all species on Earth had vanished. The dinosaurs, except for birds, were gone. The ammonites, those beautiful spiral-shelled creatures that had survived for 350 million years through multiple previous extinction events, gone. The mosasaurs and plesiosaurs, the marine reptiles that dominated the oceans, gone. The pterosaurs, gone. Entire families and genera of plants, gone. What survived? Small things, generalized things, things that could hide underground, that could eat a wide variety of foods, that could tolerate rapidly changing conditions. Mammals, which had spent 150 million years being small and nocturnal and insignificant, suddenly inherited an empty world. Birds, which were just small, feathered dinosaurs that happened to be able to fly away from local disasters. Crocodiles and turtles, which could go months without food and survive in water that provided some protection from the toxic air. These weren't the strongest or the best adapted species. They were the luckiest ones, the ones whose particular combination of traits happened to match what survival required. And here's what haunts me about this. If the Deccan Traps had never erupted, the asteroid impact alone might not have caused a mass extinction. Some studies suggest that in a healthy ecosystem, the impact would have caused massive regional destruction, maybe some global cooling, but not the complete collapse of the biosphere. The dinosaurs might have survived diminished but alive, and eventually recovered. But they couldn't survive both. The volcanic assault weakened them for 800,000 years, and the asteroid finished them off. So who killed the dinosaurs? Was it the volcanoes or the asteroid? And the answer is yes, both. It was teamwork, a tag-team murder that took hundreds of thousands of years to complete. But if we're being honest, the Deccan Traps did most of the work. They were the primary killer. The asteroid just gets all the credit because it's more dramatic, more sudden, easier to understand and visualize. But the real story is slower, crueler, and far more disturbing. Now we need to talk about the truly terrifying part of this story, because the Deccan Traps weren't an isolated incident. They were one murder in a series. And when you start looking at the other mass extinctions in Earth's history with this new perspective, a pattern emerges that should chill you to your core. There have been 5 major mass extinctions in the last 500 million years, events so devastating they show up clearly in the fossil record as sudden drops in biodiversity. These are called the Big Five. And for a long time, scientists struggled to find a common cause. What could possibly cause events this catastrophic happening at such different times in Earth's history? Surely they must have different causes, random bad luck, different disasters at different times. Except they don't. Because we now know that at least 4 of the Big Five extinctions coincide with massive flood basalt eruptions, gigantic volcanic events similar to or even larger than the Deccan Traps. The pattern isn't random, it's consistent. Earth itself, it turns out, is a serial killer, and its preferred method of murder is drowning continents in lava while poisoning the atmosphere. Let's start with the worst one. The Permian-Triassic extinction, 252 million years ago. This is the Great Dying, the single most catastrophic loss of life in Earth's history. 95% of all marine species went extinct. 70% of terrestrial vertebrate species vanished. Life came closer to complete annihilation than at any other time in the fossil record. And what was happening when this occurred? The Siberian Traps were erupting. A volcanic province in what is now Siberia, covering an area of 7 million square kilometers, roughly the size of Australia, had exploded into activity. The lava flows were so extensive that they buried entire mountain ranges. The gas emissions were so massive that they fundamentally altered the chemistry of the atmosphere and oceans. The eruptions lasted for about 2 million years, and by the time they stopped, the world had been transformed into something almost unrecognizable. The end Triassic extinction, 201 million years ago, killed off about 75% of all species and opened the door for dinosaurs to become dominant. And what was erupting at that time? The Central Atlantic magmatic province, associated with the breakup of the supercontinent Pangaea, massive flood basalts covering parts of what are now South America, North America, Africa, and Europe. The end Permian extinction wasn't just caused by the Siberian Traps we now know, but likely intensified by them triggering the release of massive amounts of methane from ocean floor deposits, creating a runaway greenhouse effect. The volcanism didn't just kill directly, it set off chain reactions that amplified the devastation. Now, here's where it gets interesting. The one major extinction that doesn't clearly correlate with massive volcanism is the Ordovician extinction, about 445 million years ago. And that one seems to have been caused by rapid climate shifts associated with glaciation. But even there, some researchers are finding evidence of volcanic activity that might have played a role. The pattern holds. What this tells us is that mass extinctions aren't primarily caused by external threats. They're caused by the Earth itself. The planet we live on, the ground beneath our feet, has a history of periodically trying to kill everything on its surface. And it's been remarkably successful at doing so. We're not living on a stable, benign platform that occasionally gets hit by random disasters from space. We're living on top of a sleeping monster that wakes up every few tens of millions of years and goes on a rampage. And here's the mechanism. Deep within the Earth's mantle, About 3,000 kilometers down, massive plumes of hot rock occasionally form and rise toward the surface. When they hit the base of the crust, they melt through it and create these enormous volcanic provinces. The process takes millions of years to build up, and once it starts, it can't be stopped. It just has to run its course until the plume exhausts itself or shifts position. We can't predict when this will happen next. We can't prevent it. We can barely even detect the early stages. This isn't like asteroid defense, where we can theoretically spot the threat decades in advance and deflect it. This is a threat that comes from below, that builds slowly in a region of the planet we can't directly observe, and that, once it starts, will continue for hundreds of thousands or even millions of years regardless of what we do. So, should you be worried? Is the monster about to wake up again? Well, here's the good news. Probably not anytime soon. The Earth's mantle moves slowly. The processes that create these massive volcanic events operate on timescales of tens of millions of years. The last major flood basalt eruption was the Deccan Traps 66 million years ago. Before that, it was about 50 million years to the Central Atlantic Magmatic Province. The timing isn't perfectly regular, but there does seem to be a rough periodicity. If you want to sleep better at night, the odds of a civilization-ending volcanic event happening in the next 1,000 years, or even the next million years, are vanishingly small. We have time, lots of time. If a new mantle plume were forming right now, we'd have millions of years of warning before it broke through the surface. That's the good news. But here's the bad news. We don't have to wait for a new Deccan Traps scale event to experience devastating volcanic impacts. Smaller volcanic eruptions, the kind that happen on human timescales, can still cause catastrophic damage to civilization. The 1815 eruption of Mount Tambora in Indonesia injected so much ash and sulfur into the atmosphere that it caused the year without a summer in 1816. Crops failed across Europe and North America. Tens of thousands of people starved. And Tambora was tiny compared to the Deccan Traps. If a supervolcano like Yellowstone were to erupt, and they do erupt roughly every 600,000 years, and the last eruption was 640,000 years ago, the effects would be devastating on a continental scale. Not a mass extinction, but certainly a collapse of modern agriculture, and potentially the deaths of hundreds of millions of people. We're not talking about destroying all life on Earth, but we are talking about ending technological civilization as we know it. And here's what's particularly disturbing. We're actually making ourselves more vulnerable to these kinds of events, not less. Our global food system is optimized for stability and efficiency, not resilience. We grow most of our food in a handful of highly productive regions and transport it around the world. If a major volcanic eruption disrupts agriculture in one of those regions or disrupts the climate enough to cause widespread crop failures, we don't have backup systems. We don't have enough food stored to feed 8 billion people through a multi-year volcanic winter. We've traded resilience for efficiency, and that makes us fragile. This is the same pattern we saw with the dinosaurs. They were exquisitely adapted to late Cretaceous conditions, which made them incredibly successful right up until those conditions changed. Then their specialization became a death sentence. We're doing the same thing. We've built a civilization that works brilliantly under current conditions, but that would shatter if those conditions changed significantly. And the really frustrating part is that we know this. We know about volcanic risk. We know about climate fragility. We know that our food systems and our supply chains and our entire technological infrastructure depend on stability that is not guaranteed. And yet we continue building systems that assume continuity, that assume stability, that assume tomorrow will look like today. Because planning for catastrophe is expensive and difficult and politically unpopular, it's easier to assume the monster will stay asleep. But the dinosaurs assumed that too. For 150 million years, their assumption was correct, right up until it wasn't. Let's bring this home by talking about what mass extinctions actually teach us about the nature of catastrophe, because I think we fundamentally misunderstand what these events mean. We tend to think of extinctions as failures. The dinosaurs failed to survive, so they went extinct, and that's sad, but that's evolution. The strong survive and the weak perish, and that's just how nature works. But that's not what the evidence shows. The dinosaurs didn't fail. They succeeded for 150 million years, which makes them one of the most successful animal groups in Earth's history. They adapted to changing climates. They evolved new forms. They survived smaller extinction events. They did everything right. And then something happened that was so far outside the normal range of environmental conditions that adaptation became impossible. Not difficult, impossible. No amount of evolutionary fitness could save them from the combination of volcanic assault and asteroid impact. This is the uncomfortable truth about catastrophic events. They don't care about your fitness. They don't care how well adapted you are. They don't care how successful you've been in the past. If the environment changes faster than you can evolve, or changes in ways that make your adaptations irrelevant, you go extinct, regardless of how robust your species is. Mass extinctions aren't tests of fitness, they're random culling events that reset the evolutionary playing field. And that should terrify us, because we're in exactly the same position. We think our technology makes us invulnerable. We think our intelligence gives us an escape route from any disaster. But intelligence and technology are adaptations for specific conditions. They work brilliantly in a stable climate with abundant resources and without major geological disruption. But in a world where the Deccan Traps are erupting, where the atmosphere is turning poisonous and the climate is swinging wildly and the food chains are collapsing, how much does technology help? How do you solve a problem that lasts for 800,000 years? The answer is, you don't solve it, you endure it. And most species don't endure. Most species die. The few that survive aren't necessarily the smartest or the strongest. They're the ones that happen to have the right combination of traits and luck to make it through. That's it. That's the whole game. So what do we take away from all of this? What does the murder of the dinosaurs teach us about our own future? I think there are a few key lessons. First, continuity is not guaranteed. The fact that things have been stable for a long time, whether it's millions of years for the dinosaurs or thousands of years for human civilization, doesn't mean they'll stay stable. The monster beneath our feet is real, and it has a history of waking up and killing everything. Second, the greatest threats often come from multiple sources working together. It wasn't just the asteroid, it wasn't just the volcanoes, it was both, plus the timing, plus the cumulative stress on ecosystems that had been building for hundreds of thousands of years. We tend to prepare for single disasters, but the real catastrophes happen when multiple things go wrong at once, when systems that are already stressed get hit with one more shock they can't absorb. Third, adaptation has limits. The dinosaurs were supremely adapted to their world, and that didn't save them when their world changed too quickly. We're adapted to our current world, but we're also actively making that world less stable through climate change, ecosystem destruction, and resource depletion. We're setting ourselves up for the same kind of vulnerability that killed the dinosaurs. And finally, the most important lesson. We know this is possible. We can see it in the fossil record. We can read the evidence of past catastrophes and understand the mechanisms that caused them. The dinosaurs couldn't do that. They couldn't look at the sky and understand that a bright dot meant danger. They couldn't measure carbon dioxide levels or predict climate shifts. We can. We have the capability to see threats coming, to prepare, to build resilience into our systems. The question is whether we'll actually use that capability. Because knowledge without action is worthless. Understanding the threat without changing behavior doesn't save you. The dinosaurs didn't know what was killing them, so we can't blame them for not preparing, but we know. We know about volcanic risk. We know about climate instability. We know about the fragility of our food systems and our infrastructure. We know that the illusion of continuity is just that, an illusion. And yet we continue living as if tomorrow is guaranteed. The Deccan Traps are dormant now. The monster is sleeping. But it's sleeping on a planet with 8 billion humans who have built a civilization that assumes it will never wake up. And when you look at the history of mass extinctions, when you see the pattern of the Earth periodically trying to kill everything on its surface, you have to wonder, are we really any safer than the dinosaurs were? Or are we just fortunate enough to be living between catastrophes in one of the quiet periods between the monsters' rampages? The dinosaurs ruled the Earth for 150 million years. We've been around for maybe 300,000. In geological terms, we just got here. We haven't even been tested yet by the kinds of events that ended the dinosaurs. And when that test comes, whether it's volcanic or climatic or something else entirely, the question isn't whether we're smart enough to survive. The question is whether we're wise enough to prepare while we still have time. Because the crime scene has been analyzed, the evidence has been examined. The serial killer's pattern is clear. We know what Earth is capable of doing to life on its surface. The only question left is what we're going to do with that knowledge. And that's a question only we can answer.